Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 3, Section 6, titled Absolute Value Equations and Inequalities. By the end of this video, you will have reviewed methods for solving absolute value equations and absolute value inequalities. You'll find yourself working on a couple of each of the two forms of absolute value problems, equations and inequalities. Finally, you will review skills for solving real-world inequalities. If you would like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find the video to be helpful. Thank you. Okay, Objective 1A, Solving Absolute Value Equations. Recall that the absolute value of a number is its distance from zero on a number line. And since absolute value represents distance, it can never be negative. Okay, just think about that. It's distance. It's not a negative distance. It's just distance. So the graph of absolute value of 3 is shown here below. And what we're asking on the graph here is to find the numbers that are 3 units from 0. So what are the numbers that are 3 units from 0? Well, 3 units to the right of 0, this way, going this way. Maybe I should pick a different color. Let's try the blue. Maybe that'll be good. So here, maybe, okay. So going here to the right, 3 units to the right here is a 3. And that's 3 units from 0. And going to the left, negative 3 is 3 units from 0. So negative 3 could be put into here, the absolute value symbol. And the absolute value of a negative 3 would be 3 because it's 3 units. Get it? Okay. You can use the properties of equality, the addition, subtraction, multiplication, division properties of equality to solve an absolute value equation. Okay, example 1, solving an absolute value equation. So it says here, solve the absolute value of x plus 5 is equal to 11. So what do we do when we see that? Well, the key thing to remember here is that you want to get the absolute value symbol or the expression of x absolute value, in our case, the absolute value of x, alone by itself on one side of the equation. So we can leave it where it is, and then we can, using the subtraction property of equality, we can subtract 5 because we have x, absolute value of x plus 5. We can subtract 5 from each side. And when we do that, we get absolute value of x plus 5 minus 5 is equal to 11 minus 5. And so you subtract 5 from each side and you get the absolute value of x is equal to 6. So then when you simplify this into the terms that it can be, x can be 6 or x could be negative 6 because they're both 6 units from 0 on the number line. Okay, example 1, check your understanding. Directions, solve each equation and then check your solution. So let's try A here. Let's look at it. I mean, because you're going to go do this by yourself first, right? But so the first one is the absolute value of t minus 2 is equal to minus 1. B is 3 times the absolute value of n is equal to 15. 4, C is 4 equals 3 times the absolute value of w minus 2. And then there's another one here that's, you have to read it and explain it. So it says, is there a solution to 2 times the absolute value of n equals minus 15? So I'll let you think about it. Go ahead and work these, and when you come back, we'll do them together. Okay, so let's take a look at A. Solve and check, right? So absolute value of t minus 2 is equal to minus 1, or negative 1. So like we said before, you treat them just like an equation. In an equation, what do? You undo the addition and subtraction first, and then you undo multiplication and division. So let's start by undoing in this case, subtraction. And we're going to do that by adding negative 2, positive 2 to each side with using the addition property of equality. So here we have, I'm going to write it out here. There it is. So the absolute value of t minus 2 plus 2 is equal to minus 1 plus 2. And when we simplify this, we're going to have the absolute value of t, okay, and this is 0, minus 2 plus 2 is 0, is equal to minus 1 plus 2 is equal to 1. So t is equal to 1 and or t is equal to negative 1. Okay, how about B? 3 times the absolute value of n is equal to 15. So there's no addition or subtraction to undo in this problem. So we're going to start with undoing the multiplication. And when we do that, what are we going to get? We're going to divide both sides by 3. So we're going to get 3 times the absolute value of n divided by 3 is equal to 15 divided by 3. Oops, 15. And we do that, this 3's here cancel, and we get the absolute value of n is equal to 5. So then that means n equals 5 and n equals negative 5. Okay, and or however we want to look at it in this case. And how about this one here? 4 equals 3 times the absolute value of w minus 2. So 4 equals 3 times the absolute value of w minus 2. So as we said before, you always, like as in equations, you undo the addition and subtraction first. So 4 minus 2 over on this side means plus 2. Plus 2 is equal to 3 times the absolute value of w minus 2 plus 2. The minus 2 plus 2 cancel. In simplification, 4 plus 2 is 6. So 6 equals 3 times the absolute value of w. And now we use division, all right? So we're going to use the division property of equality. And we're going to say that 6 divided by 3 is equal to 3 absolute value of w over 3. And that equals 2 absolute value of n, and negative 2 is equal to n. Okay, so 2 is equal to n and negative 2 is equal to n, or the absolute value of n is either 2 or negative 2. And then here, this last one. Is there a solution to 2 times the absolute value of n equals negative 15? So the question is there? Well, the answer has to be no. And why is it no? There is no solution. Why? Because no matter what you do on this side, there's no addition and subtraction. So all you can do is multiply, right? Now, if you were multiplying by a negative number, it would be okay, but you're multiplying by a positive number. So on this side, so we're going to divide by a positive number to get rid of it. And when you do, what are you going to get? You're going to get 2 times the absolute value of n is equal to negative 15. You're going to get the absolute value of n is equal to negative 15. There's a 1 in there somewhere. 1 divided by 2. And that means that n is equal to negative 15 divided by 2 is negative 7 and 1/2. Well, can you have that? Can you have n be equal to, in this case, going to be negative? You can't have a negative here, right? Because you can't have the absolute value be a negative number. It can't. Because it says the absolute value of the number has to be positive. It's a distance. So there it is. It cannot be negative. Okay, objective 1B, it's the second slide of solving absolute value equations. Some absolute value equations, such as the absolute value of 2p plus 5 equals 11, have a variable expression within the absolute value symbols. The expression inside the absolute value symbols can be either positive or negative. The expression inside can't be either, because it's the absolute value is going to give you a positive when it's done anyways. So we're going to look at this. To solve an equation in the form of the absolute value of a is equal to b, where a represents a variable expression and b is not equal to 0, solve a equals b and a equals negative b. So we're going to see how that works. But we're going to solve two different equations here, one with it being set positive and the other with it being set negative. So example 2, solving an absolute value equation. So let's try one. It says solve that the same one we looked at. The absolute value of 2p plus 5 equals 11. So as you see, there's two solutions. There's a solution here on the left-hand side, and there's going to be a solution there on the right-hand side. And we're going to follow them both down. So we start off, here's the 2p plus 5 equals 11. So we start off with 2p plus 5 equals 11 on one side, and we have 2p plus 5 on the other side equals negative 11. Okay, so now we solve each one as we normally would. So in our case here, we have plus 5 on with the 2p, so we're going to have to get the 2p by itself. So it means we're going to subtract 5 from both sides. If you go over here, you're going to do the same thing. You're going to be subtracting 5 from both sides on the right-hand side. So what happens once you do that, these 5s are going to cancel and these 5s are going to cancel. Your 11 minus 5 is going to be equal to 6, right? 2p equals 6. On the other side, 2p is going to be negative 16 because we started with negative 11 and now we're subtracting 5 more, so it's negative 16. So this 2p plus equals 6 on one side, 2p equals negative 16 on the right-hand side. This is the way you have to solve these equations, okay? So now we're going to get rid of the p, the two p's, the 2's, and get p by itself by dividing using the division property of equality. We're going to divide by 2, okay, on both sides, and that's going to give us p equals 3. And the other side, we're going to divide by 2 on both sides. We're going to get p equals negative 16 divided by 2, negative 8. So our solution to this is p equals 3 and p equals negative 8. There's our two solutions. So the value is for p is 3 or negative 8. Okay, example 2, check your understanding. So here are 3 problems that are just like the one we just did. So we're going to ask you to pause the video and work these out with a pencil and paper. And then when you come back, we'll work them together, okay? So I'll wait for you. So solve each and check. So the absolute value of c minus 2 equals 6. So what do we have to do? We have to write two equations, right? We talked about it. We're going to write one that says c minus 2, c minus 2 is equal to 6. And then the other side is going to be c minus 2 is equal to negative 6. And just it's simple. We're going to subtract 2 or add 2 to both sides. So we're going to get c minus 2 plus 2 is equal to 6 plus 2. Over here on the right hand side, we're going to get c minus 2 plus 2 is equal to negative 6 plus 2. And we're going to simplify this. We're going to get c, because these cancel. C is equal to 6 plus 2 is 8. And on the other side, c, these cancel. C is going to be equal to negative 6 plus 2 is negative 4. Okay, negative 4 and 8 are our two answers. How about B? Going to do the same thing. Now, and just keep in mind, this right now says it's negative, right? The absolute value of some number here, t plus 2, is negative 5. So the absolute value of whatever's inside here has to be positive. So right off the bat, you know there is no solution. Because the absolute value of whatever this is in here cannot be a negative number. So let's do C. So we're 7D is equal to 14. And the other one is 7D equal to negative 14. And when we do this, what do we get? We're going to divide both sides by 7. So 7d divided by 7 is equal to 14 divided by 7. And that equals 2. And in the other one here, we have 7d, excuse me, just d. We already have the 7d equals negative 14. Now we're going to divide both sides by 7. So we're going to get, again, like we just did, 7d divided by 7 is equal to negative 14 divided by 7. And these cancel, so we get d is equal to negative 14 divided by 7, negative 2. So our two answers here are negative 2 and 2. Okay, objective 2, solving absolute value inequalities. You can write absolute value inequalities as compound inequalities. The graphs below show two absolute value inequalities. Let's look at the first one here. On the left-hand side, it says the absolute value of n minus 1 is less than 3. And the other one on the right-hand side says the absolute value of n minus 1 is greater than 3. Okay, so when it's less than 3, you see the picture you have, and it doesn't have the equal sign. So there is no equal sign right here, right? So the absolute value, it says it's a circle, not a dot. So there's these, in our case, the solutions here are negative 2 and 4. And there's not dots, there's circles. So we're not including. So we have the absolute value of n minus 1 is less than 3. So how does that solve? So you take the absolute value of n minus 1 less than 3 represents all numbers whose distances from 1 is less than 3 units. Okay? All values minus 1 is less than 3. So we're going to do this again. We're going to say n minus 1 represents n, that's the value of n minus 1 is less than 3 represents all numbers whose distance is 1 from 1 is less than 3 units. So negative 3 is less than n minus 1 is less than 3. So that puts the values in between the two terms, negative 3, or in this case, okay? So 2 and 4 give you the solutions of negative 3 and positive 3. And then for the opposite here, we have the absolute value of n minus 1 is greater than 3. As you see, it's still not an equal sign. So this is still a circle, not a dot. But absolute value of n minus 3 is greater than 3 represents all numbers whose distance from 1 is greater than 3 units. So n minus 1 is less than minus 3, or n minus 1 is greater than 3. Okay, so we see the sign changed right here. That's kind of something to recognize. That when we had the greater than up here and we put the negative term in and the positive term, the negative term flips and goes the other direction. So let's look at the rule on this. To solve an inequality in the form absolute value of A is less than B, where A is a variable expression and B is greater than 0, solve negative B is less than A is less than B. That's what we did right here. Negative A is less than, negative 3 is less than A is less than 3. Now, on the other one, to solve an inequality in the form of absolute value of A is greater than B, where A is a variable expression and B is greater than 0, solve A is less than negative B, or A is greater than B. And that's what you have here. So it's less than or greater than. You see, there's similar rules apply with the equal sign, right? Greater than or equal, except it would be dots and not circles on our number line. Example 3, solve an absolute value inequality. So let's do it. So absolute value of v minus 3 is greater than or equal to 4. So, and graph the solution. So we'll draw the line that they're talking about. So when they solve this, you see that we have, on the left-hand side, we have V right here. V minus 3 is less than or equal to negative 4. And on the right-hand side, it's V is minus 3 is greater than or equal to 4. So when we do this, we're going to take and subtract 3 on both sides. We're going to, or add 3 rather, to both sides to get rid of the negative 3 with the V. And when we do that, we're going to have, it's going to end up canceling out the 3's, and negative 4 plus 3 is going to be negative 1. Okay. So it's going to be V is equal to negative 1. And on the other side, we're going to add the 3 to both sides, and you're going to get V is greater than or equal to 7. So what do we get? We get V is less than or equal to negative 1, or V is greater than 7. Okay? So that's how those solved out, the solution to those. Oh, we want to graph it too. So to graph it, we're going to have the graph, okay? Arrows on both sides, and you're going to get a number here. We're going to call that 7. And on this side, we're going to call this negative 1. And this is V is less than or equal. We got a dot for the equal on both of them. Okay. And on the left-hand side, it's going to be V less than negative 1. So it's going to be everything. I'm going to do is change colors. Let's try this. It's going to be everything to the left. And on the right-hand side, let's go with orange. Over here, it's going to be everything going to the right because V is greater than. Okay. Example 4. Now we've got a real-world problem here. The ideal diameter of a piston of one type of car engine is 90.000 millimeters. The actual diameter can vary from the ideal by at most 0.008 millimeters, 1,000th of a millimeter. That's pretty small, those numbers are. Find the range of acceptable diameters for this piston. So what's the range of diameters that this piston can be to fit into this specification that says 90 millimeters plus or minus 0.008? So we're going to let D equal the actual diameter in millimeters of the cylindrical part, the part we're going to measure. Oh, here, this one is so many millimeters. We're going to measure it. We'll call that, whatever that value is, it's D. We don't know what it is. We're trying to find out what are acceptable diameters. And so there's going to be a larger diameter and a smaller diameter, right? So allow it here. And so we're going to relate the difference between actual and ideal. The difference between the actual diameter and the ideal diameter. The ideal diameter was this, what they said is the spec. This 90 would be perfect. If they were all 90, it'd be like, wow, these are perfect. Right? So is at most. So the difference between the two is at most, cannot be any larger than, so it's less than or equal to, right? 0.008 millimeters. So here we have, we're going to write D, the measured value, minus the actual, what we were hoping for, is going to give us some difference. And that difference has to be less than or equal to 0.008. So let's look at it. The absolute value of D minus 90.000 is less than or equal to 0.008. So now we're going to solve this in the same way we solved the other ones. We're going to solve this by um, writing this with the negative, okay, 0.008. We're going to say negative 0.008 is less than or equal to D minus 90.000 is less than or equal to positive 0.008. So you got the negative on the one side and the positive on the other one. That's the difference, a negative difference or a positive difference. So negative 0.008 plus 90 is less than or equal to D minus 90 plus 0.000 plus 90, because what are we doing? We're adding 90 to we're going to use the additive property of equality to add the value we want to all three terms, because we're going to get the piston size. We're going to get 90, which is the ideal piston, minus 8 thousandth of a millimeter, And on the right-hand side, we're going to get 90 millimeters, the exact one we want, plus 8 thousandths of a millimeters, thousandths of a millimeter. And what does the answer come out to? It comes out to the 89.992 is less than or equal to D is less than or equal to 90.008. Though that means that the pistons can range as you pull them off the line and measure them. They must be, according to the specification from the manufacturer or the manufacturer, that the actual diameter has to be between 89.992 and 90.008 in order to be considered a good piston. Okay, here's checking your understanding. Let's give this a try. The ideal weight of one type of a model airplane engine is 33.86 ounces. That's the ideal weight, right? This is the one they want, that they like, the 90 from our previous one, right? The actual weight may vary from the ideal by at most, that's the minus or less than or equal to, right? 0.05 ounces. Find the range of acceptable weights for this engine. This is exactly as we just did. Go ahead and take your time, try and solve this, and when you come back, we'll work it out together. But you can go back and look at the previous slide back in the video, and see how we did that slide if it'll help you. Okay. Okay, so let's go ahead and look at this. The ideal weight of one type of model airplane is 33.86 ounces. The actual weight may vary from the ideal by at most 0.05 ounces. Find the range of acceptable weights for the engine. So we let E be the actual engine weight. We could have been W. I chose E. So E minus 33.86, that's the ideal, has to be less than. So what we pull off the line and you subtract the ideal from it, that little bit that's left over has to be less than or equal to 0.005. And then to solve this, since it's an absolute value equation, we're going to write on the left-hand side, we're going to say negative 0.005 is less than or equal to E minus 33.86. And that is less than or equal to 0.05 ounces on the right-hand side, the positive value. Okay, so now we have to get the E by itself, and doing that, we're going to what? You're going to add the three items, but to cancel out the negative, right here's this negative value. We want to cancel that out, so we're going to add 33.86 to all three terms. And this is going to get 33.81 is less than or equal. That's the minimum amount we can be. And E is less than or equal to 33.91. So our measurements all have to be within those numbers, between those two numbers, or equal to those numbers. You cannot be greater than in any way. So the range of acceptable weights for this engine are between 33.8 and 33.91. I should say 33.81 and 33.91 ounces inclusive. And when you see the word inclusive, that means that it's the equal part, right? You're including that number, right? So in this case, it can be as much as 33.91. Doesn't have to be less than that. Not a circle. It can be the dot. Okay,